Now let's have a little look on how we would separate the declaration of our class from its definition. As of now, our soldier class from the last video has the declaration and the definition all together. As you see, we declare our member variables right over here, and we declare and define our member functions all inside of the opening and closing brace of the class declaration. And that is not exactly the point of object-oriented programming. In object-oriented programming, we would only like to expose just the declaration of a class and hide away the details of the definition somewhere else, so that anyone who's going to use your class won't butt into the business of how exactly that class works, and looking at it in another way won't need to worry about how the details of the class work. So let's start over here with the attack function. I am going to do to it what we do to regular functions when we'd like to have the declaration in one place and the definition somewhere else. I'm just going to have the declaration of the function and right away finish it off with a semicolon, and then I'm going to delete the whole inside of that function. So right now, when this file will be compiled and the compiler comes up to here, the compiler will understand that this is just a declaration of a function, and the definition, the details of how exactly the function works, will come along sometime later. So now let me go to an empty spot right after the main function, let's say right over here, and over here I'm going to type the full definition of this function, as you remember when we learned about declarations and definitions of functions. However, because this isn't just a regular loose function, but it's rather a method that belongs to a class, we have to do something special to, so to speak, ask permission of that class to define the details of its method. The way this is done is by adding the name of the class, which in our case is soldier, plus 2 colons, not semicolons, 2 regular colons, right before the name of the method function. These 2 colons over here are called the scope resolution operator. It's an operator that allows us to enter the world of a certain scope, and because we declared the attack function to be part of the soldier class, that's why this attack function isn't just a plain old function that's free for all out in the open, but rather it, so to speak, belongs to a certain scope, the scope of the class soldier. So these 2 columns over here are like saying that we would like to access the soldier's attack method. If we would just leave this plain old out into the open like this, then the compiler will understand this like you're trying to create a different function altogether, like a regular function that doesn't belong to a class. When we specify the scope to which this function belongs to, then of course it will make this function be defined inside the world of that scope. So again, here we have 2 function declarations which look very similar but of course are very different. We have void attack function declaration inside of the class soldier, and right over here I made another void attack function which is not inside of a class. These are both declarations of functions without definitions. Then let's scroll to the bottom. Here we have the definition of those functions. This one right over here will be the definition of the attack function that belongs to the class soldier, and this one right over here is the definition to the regular attack function we declared before, which does not belong to any class. That's why, as you've noticed, I took out the strength variable out of here, because according to this function there is no such thing as a variable strength. However, in the soldier class of this method right over here, there is such a thing as a integer strength. Back to the declaration of the soldier class over here, I just removed all of the definitions of the functions that we had before, and I just turned everything into only declarations. And this would be the ideal way how you would design a good object-oriented class, which pretty much just shows us a bare minimum of what we need to know about this class. We know that it has these member variables, and we know that it has the ability to attack, to heal, to be attacked, to get health. We know that this function over here returns an integer, and we know that the others do not. We see over here a constructor which gives us the possibility of creating soldiers with initializing values. So just by looking at this stuff right over here, we get a perfect picture of everything we need to know really to be able to use this soldier class. So if it would all be messed up and crowded with a whole bunch of definitions and details of exactly how each one of these functions work, that wouldn't be the point of object-oriented programming when a programmer wants to review how this class works. Whenever you want to just review how a class works, you don't care the specific detail of everything that's going on in the functions. You just want to know, what do we have here? What functions do we have? What variables do we have? And stuff like that. So this is all we want programmers to be looking at. The dirty details of the implementation, the definition of all of these functions, we'll hide that somewhere else where no one will care looking at. Over here in my main source file, the tutorial.cpp file, I put the definition of all those functions after the end of the main function over here. This is where I explain the definition of all of those functions we declared in the soldier class. And as you can see, they all need to have this permission to be playing around with methods that belong to the soldier class, which is done with using the class's name and 2 colons. You still have to have the return type, don't forget about that. That has to come in the beginning. And this name of the class with 2 colons comes right before the name of that function. And from there on, you just continue to define your function like any other regular function. So it passes variables and it does stuff and stuff like that. Here we have our definition of the class's constructor. The constructor function itself also, we didn't have the whole definition in the class. We just had the declaration of that constructor function, and now over here we will be defining it. So we need to access the soldier class again by doing the class's name and 2 colons, and then we put the function's name, which happens to be the constructor, so it's the same word like this one, whatever the class's name is. Of course, a constructor doesn't return any variables, so it does not have any sort of return type like I explained in the other video. And then you could just go ahead and pass your variables, start your initializer list, and initialize the class's variables and stuff like that. Pretty much all the other rules of regular functions apply to method functions. For example, since we declared all of these functions, the whole soldier class, since we already declared it before, even though we didn't type the whole definition of the function, we only have the declaration, that will already be enough to be able to right away start using those functions, because the compiler will figure out that when I call the attack function, I want to execute the definition of the attack function, which is right over here. So the compiler takes care of figuring out that little thing. And also rules like you don't really have to put a name of a variable over here. You could just leave it empty like that, integer and integer, and over here too, integer. If you'd like to, you could type a name over here, and the name over here, meaning over here in the declaration, does not have to match the name in the definition. So over here I could make this integer x and y, and over here z, and then in the definition of the function I give it a different name, like start strength, start health, and over here amount health. Then of course you must always make sure that you pass the correct amount of variables and the correct types of variables to the correct functions that require it. Otherwise I would get a compiler error. For example, if I would try to call the heal function without passing it a variable, or if I would try to pass something inside of a function which does not take any variables, like be attacked over here. So unless a difference is specified, the rules of functions are always the same, whether it's a function in a class or a function out of a class, like this one over here.